In 2006, a chip company spent years building a piece of software that almost nobody wanted. Gamers didn't care about it. Wall Street didn't understand it. And for 6 straight years, it looked like a very expensive mistake. Then, in 2012, 2 graphics cards in a university lab quietly triggered one of the biggest technology booms in history. And they turned that so-called mistake into one of the most valuable software platforms on Earth. Back in 1993, 3 engineers, Jensen Huang, Chris Malachowski, and Curtis Preem, started a company called Nvidia. They had about $40,000. Their idea was pretty simple: build chips that could make video games look better. And for more than a decade, that's exactly what Nvidia was, a graphics card company fighting for gamers' money. But in 2003, something interesting happened. Nvidia's engineers made a quiet decision that had almost nothing to do with gaming. They added a new kind of mathematical capability to their graphics chips, the kind normally used in scientific computing. At the time, it seemed like a tiny technical detail almost nobody outside Nvidia noticed, but that decision planted a seed. A year later, Nvidia hired a Stanford researcher named Ian Buck. He had just finished his PhD on using graphics processors for general-purpose computing. Nvidia paired him with its architecture lead, John Nichols, and together, they spent the next 2 years building something pretty unusual, a way for ordinary programmers, not just graphics experts, to use gaming GPUs for massive parallel calculations. In November 2006, Nvidia finally released it to the public. They called it CUDA, Compute Unified Device Architecture. The official software release followed in 2007. On paper, it was revolutionary, but in the real world, almost nobody needed it yet. And this is where most business stories would probably end. Nvidia had spent years building something with almost no obvious market. For 6 years, the company kept pouring engineering resources into CUDA, and people started asking a very reasonable question. Why was a gaming chip company spending so much money on scientific software that almost nobody was using? But Nvidia kept going. Jensen Huang pushed the company to release a new GPU architecture, roughly every 2 years. The pace was so aggressive that people inside Nvidia eventually started calling it Huang's Law. It was a huge bet. The company believed that someday, somewhere, the world would need exactly what CUDA could do. They just didn't know when, and they certainly didn't know what would trigger it. Then, in 2012, everything changed, and surprisingly, it didn't happen inside Nvidia. It happened in a university lab in Toronto, the University of Toronto. Researcher named Alex Krzyzewski built a deep neural network called AlexNet, and he trained it using 2 Nvidia GTX 580 graphics cards running on CUDA. Then, he entered AlexNet into a computer vision competition called ImageNet. What happened next shocked the entire research community. AlexNet didn't just win, it crushed the competition, and suddenly, researchers realized something that had been hiding in plain sight. The hardware needed to make deep learning actually work had already existed for years. It was sitting inside ordinary gaming computers, and it was running Nvidia's CUDA software. That realization changed the direction of the entire technology industry. What followed wasn't a slow transformation. It was an explosion. Within a year, companies like Google, Facebook, Microsoft, and Baidu were racing to adopt GPU-powered deep learning. Nvidia was no longer just selling graphics cards to gamers. It was becoming the company behind the computing infrastructure of the AI revolution. Then came 2022. ChatGPT arrived, and suddenly, the entire world started paying attention to Nvidia. The company's market value soared past $1 trillion, and eventually past 3 trillion Jensen. Huang has described CUDA as more than just software. He calls it the engine of a self-sustaining CUDA flywheel. More developers use CUDA. That makes the platform more valuable, and the more valuable it becomes, the more developers want to use it. By 2026, Nvidia still controls roughly 80 to 86% of the data center AI chip market, depending on the analyst. But the competition is getting stronger. AMD's open-source ROCm platform has improved dramatically. AMD has also landed major supply deals with companies like Meta, Microsoft, and OpenAI. And tools such as OpenAI's Triton compiler are making it easier for developers to write code that isn't completely dependent on Nvidia hardware. But despite all of that, most of the world's leading AI labs still default to CUDA when they train their biggest models, and that habit wasn't created overnight. It was built over nearly 20 years. So, what's the real lesson here? CUDA isn't really a story about chips. It's a story about patience. Nvidia spent years building something that almost nobody needed because they believed that eventually someone would. And when that moment finally arrived in a university lab in Toronto, Nvidia was ready. That's what makes this story so interesting, because almost every so-called overnight success in technology has a story like this hiding underneath it. Years of unglamorous work, years of uncertainty, years of building something before anyone could see why it mattered. CUDA wasn't simply a lucky bet. It was a decade-long head start that almost nobody else was